All right, guys, tonight we're going to do an exceptionally unique build from start to finish. And the theme of this build is called the Scrap Pile Challenge. We've probably all heard of Junkyard Wars or Scrap Heap Challenge, and that is kind of what we're doing here. You know, I've built a lot of machines, and when you work in that world, you always wind up with bits and pieces that you'll never use in a good machine. And so they wind up in the scrap pile or on the shelf. And so the idea here is to pull some of those parts off the shelf and somehow use them to create something neat. If you notice on the splash page for this video, you saw on the front of the case a label that said Intel 486 and a label that said Pentium 4. You weren't mistaken. And so that's what we're going to do, is we are building a machine that has a Intel 486 and a Pentium 4 inside of it. To accomplish this type of task, there are going to be a lot of engineering challenges. There's going to be packaging, there's going to be heat dissipation, all sorts of issues, routing issues, and to overcome those issues, you have to make compromises. You might use boards that are suboptimal. The point is not to build the machine that does everything and that does everything the best. It's to build a machine from parts that are basically disused or fall outside of the norm, and adjust the expectations for what are the most appropriate games, and then build it, test it, benchmark it, and at the end of the day have fun with it, especially knowing that you used parts that most likely had no future. So my objectives here are to build this machine from start to finish in the video, but first go through and introduce the parts we're using, the background of them, you know, what makes them unique, what put them into the scrap pile, what their disadvantages are, what their advantages are, and then develop a strategy to put all this together into a system that will run, it'll run correctly and stable. The case we're going to use tonight is what I'd call a 386/486 era AT desktop case. Fairly standard arrangement. It's got 3 5¼ inch bays, 2 3½ inch bays, and has enough depth to accept a baby AT motherboard and full length cards. It has a 200 watt AT power supply, which is pretty typical for a machine of that era, and right now it sits empty otherwise except for the drives. What we have in the foreground here are the 2 motherboards we're going to use for this build. These boards are not mainstream boards. These are boards that are typically not used in anybody's prize build. These are truly the boards that wind up in the junk pile. But what makes them unique also makes them able to be used together in this idea of being inside the same case. The 486 motherboard is a FIC 486J. Now, this is probably one of the earliest Intel 486 motherboards you're ever going to find. It has a VIA 82C470 chipset, which is actually the first chipset VIA ever released for a motherboard. The CPU is a SX25 with the PQFP packaging. Right now it's got 8 megabytes of SIM memory on it, and it's got 0 L2 cache. And it also has a rebuilt Dell's clock chip. So this definitely qualifies as the scrap heap 486 motherboard. Not a whole lot of people would want to use this. This is really more comparable to like a mid-range 386. The Pentium 4 side of this arrangement is actually a single board computer, and the brand is Norco. It's a model 830, and it's a Pentium 4 Northwood core. It's actually kind of the last of the 103 millimeter Northwoods. It's 2.8 gigahertz, and it has the hyper-threading capability on it. The main chipset is an Intel 865G, and that includes integrated Intel graphics, which is the 82865 Intel Extreme 2 graphics. Right now it's got a pair of 256 megabyte DDR SIMs totaling 512, dual IDE channels, floppy, parallel, serial, and USB. And then it's got actually 2 Ethernet ports, and then it's got a PS2 breakout for a PS2 mouse and keyboard. This actually uses a Y-splitter dongle. Now, what's really unique about this single board computer that it's very difficult to find anywhere else is it actually has a dedicated ATX header on it. So you can power this by itself without an active backplane, which is really unique and really makes this build work. For the 486 side of this build, we're going to use a standard multi-IO controller card. So this has IDE, floppy, 2 serial ports and a parallel port, very standard for a 486 without integrated controllers. We're going to use a Diamond Speedstar VGA. This is a 1 megabyte VGA card, ISA bus. You know, kind of a scrap pile card. I mean, it's not the kind of thing you'd use for most 486 era games, more like a 386 card. The sound is actually by no means a junk pile card. This is a Creative Labs CT2770 Sound Blaster Value. And what's nice about this card is it has the CT1747 chip. So this has the integrated Yamaha OPL 3 on it. So this gives good sound output. To support the Pentium 4 SBC, this is the breakout cable for the PS2 mouse, and actually it's an AT keyboard, but you can use a PS2 keyboard as well. This is the USB breakout header. It'll go to the back of the case. This SBC does not have built-on sound, but we're going to use one of these USB external sound codecs, and you'll be amazed by what this does in Windows 98. The power supply we're going to use to support the Pentium 4 is a SFX form factor power supply, but otherwise has ATX type headers and output. And both systems are going to be ran off of compact flash IDE adapters. The concept for the operating systems on these two boards are going to be, on the Pentium 4 side, we're going to run Windows 98 2nd edition. Fortunately, this board is very well supported in terms of drivers, and I think that, you know, given this Pentium 4 2.8 gigahertz, and that it has the integrated Intel graphics, which, you know, is no GPU. I mean, it's no GeForce 2 or whatever. But I think if we narrow the focus of what games we play, you know, in particular late 90s games, you know, games that are the early DirectX under Windows 98, I think it's going to perform well, and especially if we set our expectations to use, I'll say, lower to moderate resolutions. I think it'll be a good time, and we'll go through some of that gameplay. For the DOS side of it, we're going to run DOS 6.22 in a real simple configuration. You know, it'll be set up to do DOS games from, you know, 1989, 90, 91, 92. So it's going to use HiMem.sys, EMM386, maybe even some EMS, and then we'll have the Sound Blaster set up to give, you know, appropriate sound support. And we're also going to use the MPU 401 output of that sound card to drive an external synthesizer, and I think we'll have some really good music opportunities, especially like MT32 emulation. Let's talk about the strategy of how we're going to integrate all this hardware into one case. So looking at it from the front view, we have 3 5¼ inch bays and 2 3.5 inch bays. Normally there would be a detachable sled in here that you could mount your drives in. Obviously we're going to keep the 2 floppy drives for the 486 side. I haven't decided if we're going to populate this bay or not. In concept, there could be a CD-ROM drive that could service either side of this machine, but it's not clear to me how crowded it's going to be, so we'll reserve that for later. Let's flip this around. So the idea is going to be that we're going to mount the 486 board in this area, and then reserve this real estate for the power supply that's going to support the Pentium 4 SBC. And then the Pentium 4 SBC, given that it's a full-length card, can actually rest in here, and it's the exact right length to engage the rear slot bay, as well as this retaining clip that's normally used for full-length cards. Now we're obviously going to have to solve the problem of how do we isolate this SBC card from the 486 board that's going to be in here and have absolutely no interaction between the two. Flipping this back around, let's take a second look at the front panel here. So in the normal function as a 486, we have our power toggle, we have our turbo switch, which is a 2-state type switch, and then we have our reset button, which is a momentary. So what I want to do is appropriate this momentary button to actually be the ATX button for the Pentium 4 SBC. So really, when we walk up to it, we can power on the 486 like normal, and then we'll be able to power on the Pentium 4 just using this button. And this turbo button will retain its function for the 486, which will be cool because that can really slow it down to like slow 286 AT type speeds, so we can even focus on older games, possibly going back to the XT era. Let's begin the integration of the 486 side of this computer. We're going to have 6 points of contact between the motherboard and the case itself. There are 2 stamped standoffs already built into the case. There's going to be 2 screw-in steel standoffs here, and then 2 plastic barb type standoffs here. So this board will be plenty secure. Next, we have to plan the arrangement of the interface cards. So we've got a multi-IO card here to support the floppy drive, hard drive, and serial ports. We got the sound card, we got the video card. Now logically, we want to put the multi-IO card closest to where the drives are going to be, so the ribbon cables have the best path. And so we'll put that into this slot here, and then we'll put the sound card and the video card in these 2 slots here. Let's do a quick power on self-test just to make sure everything works at this point and there's no surprises. Go ahead and slide our screen up front here, and let's turn it on. Excellent. Next, we're going to attach the cables for the floppy drives. We're going to install a compact flash adapter and compact flash card. We'll attach the keyboard. We'll start it up again. We'll go into the BIOS, take a quick look at it, and then let's look at what we have in terms of the operating system and the software layout. Always remember when you install your power header for your AT motherboard that the grounds are on the interior. So you can see here, there's a total of 12 pins. There's 6 and 6. And each of these headers have a pair of black ground wires. You have to make sure that they're situated towards the interior, not the exterior of the arrangement. So when it's properly installed, you'll have 4 black conductors on the inside, not on the outside. Let's go ahead and pull the floppy ribbon cable out. On these ribbon cables, there's always going to be a red stripe on one side that corresponds to pin 1. On this floppy controller, pin 1 is situated on this end of the card for both the floppy and the IDE. So we make sure our red stripe is aligned here. On this particular compact flash adapter, its pin 1 is situated towards the red LED or where the bird connector is on this side. So we'll install it this way. Then we'll fish our external power bird connector out and install. Now that we have all the drives attached, let's go ahead and fire it up and go into the BIOS setup. Alright, let's visit the first screen. We've got the correct time. We've got our 1.44 and 1.2 megabyte floppies defined. Let's go into the auto detect menu. So I've installed a 512 megabyte compact flash card. This BIOS is a pre-LBA BIOS, and so it's not going to do well with any drive that is logically greater than 1024 cylinders by 16 heads by 63 sectors per track. And so this 512 flash card shouldn't be a problem. And it does detect it properly. All right, so we got that in there. Let's go into the advanced CMOS setup. So what's notable here is, yeah, we're gonna have floppy drive seek at boot. I like that. Boot A before C. We'll have the CPU speed high, internal, external. It's funny, there is no external cache, so this is a pointless option, but leave it that way anyhow. One thing that we probably can, or right now the this section is set for auto configuration, and we've got the fastest wait state settings, so I'm not sure if these are actually being ran or not, but let's leave it this way until we find a reason to change it. But I will say though, so for the AT clock speed, right now it's set for CPU clock divided by 5. So this particular arrangement is a 25 megahertz clock, and so divided by 5 would be 5 megahertz on the AT bus, which that's just too slow. So let's see what we got. We got 6, we got 4, 1.5, 1, 2, 3. So 25 divided by 2.5 is 10. 25 divided by 3 is 8 1/3, which is kind of the standard speed for a AT bus. But let's go with the 25 divided by 2.5, so that's 10 megahertz. Let's hope things are stable that way. Let's go ahead and save the changes and keep moving along here. We can hear the drive seek. All right, excellent. I've already installed DOS 6.22 on this compact flash card, and I've also set up the basic Sound Blaster drivers, a couple of different memory arrangements for EMS or no EMS, and maximized for conventional memory. So what I'm going to do here is just go through and demonstrate that this machine has basic function, has basic Sound Blaster capability. And then once we see that, we'll go back to the Pentium 4 build side of this, and we'll eventually come back around and look at the 486 again when we get into the more advanced features like the MPU 401 output, and then we'll look at quite a few other games that have great music. Let's take a look at Wolf 3D. Let's finish up some of the fine details on the 486 side. This wire loom has the wires that go to the front panel controls and LED. So this 5-pin loom is for the combination keyboard lockout switch and the power LED. This is for the PC speaker. This is for the turbo switch, and this is for the turbo LED. Now we're not going to have reset switch function on this 486 because we've appropriated that switch to the ATX power for the Pentium 4 SBC. So we'll leave that pin unattached. And then this pair goes to the multi-IO card for the hard drive LED indicator on the front panel. Let's go ahead and integrate the Pentium 4 side of this into the case. This discussion is primarily going to be about the power supply and about the SBC card. The power supply is a 380 watt SFX form factor power supply, so it's relatively compact. And it's going to be placed in the area where the 3.5-inch drives would normally reside. Now, this is, I consider to be a mock-up, proof of concept prototype, temporary type installation. Normally I would create more permanent rigid bracketry, but for the case of this trial, I'm going to use some high strength Velcro to keep it in place just for this evaluation. And what I've done here is I've routed a regular PC 110 volt power plug inside the case so they can plug into the normal AC input for the power supply when it's installed. And then the other end of this safely goes through the rear of the case through a plastic grommeted port. And then up here we have the Velcro that's going to keep it in place here against this. And again, this is temporary. This is just for proof of concept. So I'm going to plug this in. There's no power, but I'm just attaching it. And we're going to put that down in place here. And so the idea is that the cool fresh air is going to get drawn in through the front panel and get expelled out towards the side of the SBC where the Pentium 4 is, that has its own integrated fan. And there's also a 60 millimeter fan inside the case here that's drawing air in through the case's front grills that also adds to the cool air injection. And then my expectation is that the warm air will make its way through here and the primary AT power supply will be the heat rejection. So once we get this set up and running and under load, I'm going to do some additional measurements using CPU temperature measurement tools, as well as some actual physical thermocouple temperature measuring devices, just to make sure we have a reasonable situation. All of the additional power leads I've bundled up, and I'm just going to tuck underneath into the unused drive bay. Normally I would trim these out or find maybe a modular power supply, but for the time being, we're just going to keep them out of the way. And then what we have left really is just the ATX and Pentium 4 power taps. Let's go ahead and place the Pentium 4 single board computer. Now what's vital in this arrangement is that this SBC is secured on each end as well as on its edge connectors. And what's obviously an issue is these edge connectors are energized and they have to be electrically isolated from anything else around them, especially this ISA slot. So what I've created is a plastic 3D printed saddle that securely mounts on top of the ISA bus, and then has a slot for the SBC's edge connectors to fall into, and there's plenty of thickness between these two to keep them isolated. Go ahead and drop that in. There we go. Now, because of this height offset, that affects, the screw tab. And so what I have is a standoff grommet and a long screw. So this plastic grommet is going to take up the space between the case and the bottom of the SBC's screw flange, and that'll keep it in place. Let's go ahead and install that spacer. So this is well placed. We'll install the ATX power header, the Pentium 4 additional power, and then this is the momentary ATX switch for the power on, power off, and we'll put that on the appropriate location here. What I forgot to install was the USB rear panel header, so I'll do that here in quick time lapse. We have the USB headers attached. We have our ATX power reattached. Last thing to do is the 4 GB compact flash card. We're going to put this into the lower of the two ID channels because that is how tight we are on clearance relative to the case. Looking at the rear of the case, on the 486 side we have our AT keyboard port, parallel port, serial port, and then the sound card and video card. And then on the Pentium 4 side, we get the single board computer, video output, dual Ethernet, and then this is a combination PS2 mouse and keyboard port. And so what we have here is this splitter dongle that will plug into there. And then we have dual USB. On the front of the case, you can see the air intake for the power supply. So what I've done is I've 3D printed a grill with the hexagonal honeycomb shape type holes. And the total square area of this grill is approximately the same as the rear of the power supply, so I'm not really concerned about this being an obstruction. So that'll be placed in there and we'll actually hot glue it from the back side. Let's go ahead and pull the front fascia off so we can get this grill glued in place. This is a really nice metal steel spring arrangement. So what I'll do is hot glue the corners lightly. This is all removable if need be, but it certainly will hold it in place. Here we got 4 corner tabs, and then I'll just let it sit upside down until it dries. The glue's dried, let's go ahead and pop that back on. The Pentium 4 section of this machine is buttoned up and ready to go. So at this point, we're going to power it up with the main case cover off, just the Pentium 4 side. We're going to run through the BIOS, take a quick look at that. We're going to let it boot into Windows 98, and we're going to look at briefly how the operating system is set up in terms of drivers. And then we're going to walk through and look at various aspects of performance. We're going to run the 3D Mark 2000 benchmark, both the demo and the actual benchmark itself. We're going to go into a DOS window and run a couple of games like Doom 2, Hexen, Quake, just to see how well the sound's supported and how it performs. And we're going to run one of my favorite games, Descent 3, just to see how the DirectX OpenGL support works. Let's plug in our sound. PS2 keyboard and mouse. Network. We're not actually doing any network right now, but Windows 98 boots a heck of a lot quicker when you have DHCP services available. And our video. We have a fairly ordinary AMI BIOS setup for a Pentium 4. We'll quickly go through some of the screens. Here we have a 4 GB compact flash card set up as an IDE device. We have the hyper-threading turned off because that's of no use in Windows 98. Just adds more wattage. Here we have the thermal active temperature set at 75°C, and that's the temperature at which the CPU will begin to protect itself if it overheats. Here we have the real-time CPU temperature, system temperature, fan RPM and voltages. Right now it's fairly steady at idle. The CPU idles around 50 or 51 C, and that's kind of normal for kind of maybe to the upper end for this class of CPU. The system temperature right now it registers at 35 C. It can be lower than that at a dead cold, or it can be quite a bit higher, as we might see here with the case on. We'll go ahead and reboot here into Windows 98. Let's take a quick peek into the control panel. In the device manager, we've got the Intel 82865G graphics controller, 2 Intel Ethernet controllers, a generic USB audio device, under multimedia, under the USB audio device, what's cool is there is a generic Microsoft GS wavetable synth that's supported, so it's going to be neat when you get into the DOS games. Let's go ahead and run CPU ID. Here you see we have the Northwood Pentium 4 at 2.8 gigahertz. Let's go ahead and run 3D Mark 2000. We'll run through the demo, and I'll show you bits and pieces of that. You don't want to spend your whole time watching that. And then we'll go through the benchmark. We'll run the benchmark at 1024 by 768. This benchmark yielded about 6,600 3D marks. In my interpretation, this is a score, this is a level of performance that will give you reasonably good gameplay for games published in the late 90s and even some in the early 2000s at reasonable resolutions. This integrated Intel chipset is not a dedicated GPU. So there are texturing features that it does not have, but it is fairly advanced. So it does some things really well and others mediocre. But I think for the scope of this machine, if we just agree that we're gonna not expect GeForce 4 or Voodoo 5 performance out of it, I think most people will be reasonably happy with this level of gameplay. Let's go ahead and spend a few minutes playing one of my favorite games in the OpenGL world, and that is Descent 3. Quick run through on the setup. So we are using the OpenGL driver tied to the Intel chipset. We are set for custom, but we're going to make sure that we have the highest settings. All right, let's go ahead and hit play. All right, real quick on the options. So we're going to run 1024 by 768 with let's kick the rendering up a little bit. Let's not go too crazy, but let's just set it there. Let's watch the demo first. And let's do a quick real-time play of me doing.
I'll check in with you shortly. Take care. Over and out.
No good playing the keyboard, so forgive me here. Let's now take a look at the DOS window support. As I mentioned before, there's a general Midi support with this sound card. So we'll go into Doom 2, and we're set up for general Midi. regular Sound Blaster support. Not bad for a $3 USB sound card. Let's check out Quake. Last but not least, let's check out Hexen. Let's turn the gamma down a little bit. There it is. And we can't forget Duke 3D. Let's go ahead and explore the 486 side of this machine. Here we have a DOS 6.22 multi-boot configuration, and in these two options we either have no expanded memory or expanded memory in the case of certain games that would require that. So for this trial we're going to use no EMS, and this arrangement is optimized for maximizing conventional memory. And so we're going to be using HIMEM.sys, EMM386 with no EMS called out, and then the load high culls of as many drivers as we can. And so we're going to have smart drive, a mouse driver, as well as the Sound Blaster CTCM loading. As you can see, we have a reasonable amount of conventional memory at 616 kilobytes. First thing we're going to do is run the DOS benchmark pack, and first thing we're going to look at is how this machine performs with its standard turbo on configuration and then the turbo button off configuration. And we'll use the landmark system speed test to compare. So with turbo on is shown at 25 megahertz, and the performance index it gives is like 119 megahertz AT or 286 equivalent. So let's go ahead and press the turbo button. and that brings us down to the equivalent of a 20 megahertz 286. So this could be interesting when you have the older games that are speed sensitive, like a lot of the ones that were made in the XT era. For laughs, let's run the Doom min detail benchmark. So if you don't mind playing Doom on a postage stamp size screen, this isn't too bad. Next, we're going to run a series of games from the 386, 486 era that either use Adlib, Sound Blaster OPL sound, or MPU 401 that's going to run to an external synthesizer, and that synthesizer is going to be running MT32 emulation. This is the original release of Wing Commander running the Creative Sound Blaster sound configuration. Here we have one of my favorite arrangements. We have the 486 set up with an external synthesizer being driven through the MPU 401 port of the Sound Blaster Creative card. For this arrangement, we're going to run the CL32A instead of the MT32 emulation on the synthesizer. Just my personal preference. I think the CL32A hits some of the sounds a lot better. Now we're going to characterize the thermal profile of this computer assembly. Up until this point, I've ran with the sheet metal case cover off, and I've seen no issues. So now we're going to put it back on and take a look at what the temperature increases are. My original goal was to use third-party software that would monitor the CPU's condition along with whatever the motherboard registers as system temperature. And every software package that I used did not accurately indicate the temperature compared to what the BIOS temperature measurement was and a few other, I'll say, physical measurements that I took. So I'm not going to use any Windows software. I'm going to stick with what the BIOS registers. And I also have a J-type thermocouple reader with 3 leads on it. And I'm going to actually put thermocouples in key locations so we can see what the temperature rises are to understand if it's acceptable. We're set up to do some temperature evaluation. So right now the machine is at dead cold, and we have 3 thermocouple channels measuring different locations. Channel number 1 is measuring ambient air temperature in this probe here, and channels 2 and 3 running through the back of the case, and specifically channel 2 is positioned in front of the internal power supply that powers the Pentium 4 machine, and that's gonna measure any temperature increase across that power supply specifically, just to make sure that it's not overheating. And then our 3rd channel is located between the Pentium 4 cooler fan and the Intel video chipset heatsink. I think that's going to represent probably the highest temperature inside the case. We're also going to take a look at the BIOS temperature values to see if they correlate with what we're physically measuring. So the process is going to be, we're going to turn on both sides of the machine, both the 486 and the Pentium 4. Of course, the 486 side is actually going to be the air exhaust mode, through its power supply. And then what I'll do is boot Windows 98, and then I'll run the 3D Max 2000 demo over and over, and that should create max CPU load. And let's see where our temperatures wind up at. Hopping quick into our BIOS temperature measurement, we can see the system temperature initially has measured at about 21 C, which correlates with our ambient. So I think that makes sense. And you can see that the CPU temperature hopped up to about 49 C, which now it's at 50. And that's not unusual for a Pentium 4 of this category. So we're going to go on to the Windows 98 boot, the 3D Mark 2000 run, and we'll see how our temperatures rise. And as we can see on the bottom thermocouple, we are getting some rise already, certainly on the CPU side and a little bit across the power supply. We've booted Windows 98, and now we're in the 3D Mark 2000 Pro start screen. I've set the demo mode to do looping, and in the time that it's taken to boot 98 and get to where we're at, the interior temperature has risen to about 30°C near the CPU, and it's at 24°C in front of the power supply, which represents about a 4-degree increase across the power supply itself. So I'll run this demo, and I'll do it in time lapse just so we can get to the end here quicker. We've ran 2 demo cycles and we're into our third, and as you can see, we're approaching 49°C air temperature in the vicinity of the CPU. In my opinion, this is totally unacceptable. If we're to let this go, I'm sure it would rise beyond 50. So what I'm going to do now is exit Windows 98 and go back into the BIOS and see what its CPU and system temperature reading says, and we'll compare. Wow, yeah. According to the BIOS, the CPU temperature is around 53, 54°C, and the system temperature hit 56 wherever it's measuring at. Yeah, so when I put my hand on the sheet metal of the case, it is certainly warm. So this is a configuration that really cannot run for any extended period of time under heavy load with the case closed. So where does that leave you? That leaves you with, well, leave the case open, which I wouldn't recommend for most people or anyone. Or we can find a new case, that has superior ventilation. So that being said, this has been a fun project. We've been able to demonstrate the ability to integrate these 2 systems under one case, and I have no doubt if we can do it in this case, there's many others, probably bigger towers with better fans, we could do the same thing. We've demonstrated that we can run a wide range of games, from I'll say the 286, 386, early 486 era with great sound, and then we can run, I'll say early Windows 98, late 90s, early DirectX type games, along with some DOS supported games under Windows 98 like Doom and Hexen. So I hope you've enjoyed this scrap pile challenge. This has been fun for me. To me, this is a good exercise in taking parts that really didn't have much of a future otherwise and creatively integrating them into a case, evaluating the performance, and in the end we evaluated the temperature configuration and found out that we really didn't have enough ventilation. So next step is going to be a new case, and we'll redo the temperature measurement to see if we can find a better solution. Thank you for watching.